Here is 2-3 day 1. It's not labeled as such, so I will do that. It's labeled as 2-3, just not day 1. There it is. Okay. 2.3. We'll talk a little bit about domain and range. A little bit more about zeros. A little bit more about graphs. A little bit about the vertical line test. Kind of a hodgepodge of function topics. A lot of them involving graphs. Which, remember, you'll kind of see, if we're going to get into graphs, that usually, that can go one of two ways, because sometimes you get some moans and groans out of students who are like, graphing, I hate graphing. Typically, that's the response to creating graphs, which is part of the deal. We'll do some of that. We have already, but not today, right? The other part of working with functions graphically is if we're given a graph and we can get some of the information that we want to from it, okay? Reading graphs, not necessarily writing them. We're not going to write any today. We're going to talk about domain and range from a graph. So if you're talking about the domain, it's always determined from the horizontal axis. Horizontal, of course, is the x. And if you want just kind of really plain terms to think about this, think side to side. Remember, the domain is all the possible x values a function can take on. We were looking at it the last couple of days as like how to get it from an equation. Okay, we call that finding domain symbolically. This is graphically. The range is determined from the vertical axis. That would be your y-axis, and if you want to just think really simple terms in terms of direction, up and down. So we'll get to that. When asked to evaluate f of x, we go to the x-coordinate to then determine the y-coordinate, okay? So if we're evaluating a function off of a graph, you use the x value first to figure out where you're going. It's kind of like go side to side, and then go up or down to wherever your y value is. And we'll do some more with zeros, but we're going to do it with some kind of different functions. We'll review a quadratic, and then we'll do a couple other goofy functions just to kind of get a variety of the kind of functions that we'd find a zero for. First things first, let's do some domain and range, okay? All right, so when I'm looking at domain, I'm thinking side to side, okay? And the thing I noticed here is this is how far to the left the graph goes. Here's how far we go to the right. So then I check out my x-coordinates. I'm like, okay, looks like -1 to 5. Notice the closed circle, which means I include that point. So I would say greater than or equal to -1. The open circle at 5, so it approaches 5, but it doesn't hit 5. So I'd have to say for my domain that x needs to be less than 5. For the range, right, switch, go vertical, up and down, up and down, up and down. You can see them marked right here. Goes up to there, right? Because notice up here, there's nothing there, right? I draw like a line, but at that height, I'm up at like, it's not really a perfectly horizontal line. It's at about y equals 5. It doesn't touch the graph, okay? It doesn't touch the graph. That part of the graph isn't in the range. It's got closed circles at both the top and the bottom. Looks like the bottom goes down to -3, because now I'm checking these y values. And up at the top goes all the way to 3, okay? In between there, the graph is continuous. There's no gaps or anything like that I'd have to worry about, okay? domain and range off of a graph is not too bad. If you know what you're looking for, it's pretty straightforward. All right, let's talk evaluating. F of -1, right? So we said on our notes on the slide before, use the x value. In this case, that would be -1. So I go over to here, and then I need to go up or down until I get to the graph. And there I touch it. So it looks as though f of -1 is 1. And sure enough, you can see that point is labeled, right? -1, 1 is a point that the graph goes through. Let's do f of 2, right? Go to your x value first. Which would be 2. And then I can see the graph is down here, so I go down, and there's the point right there. -3. Zeros, okay. We've done a lot of work finding those, but with a graph, you don't have any algebra to do. I just need to look. I'm going to clear out this graph again. Looks like right there and right there. Those are the two places that it crosses. Looks as though it's x equals 1 and x equals 4. None of it too bad, right, to get all that information from a graph, okay? Again, stay focused on reading, right? I'm not going to create any graphs. Could you get that kind of information from a graph that you're given? All right, vertical line test is another aspect to reading graphs. It really has a pretty fundamental purpose. If we're talking graphs, we are typically talking about functions, okay? Not every graph we see is labeled as a function, okay? Because we've talked before in Chapter 2 that it's got a pretty specific rule that when you're given an x value, it can only go to one y value. If it breaks that rule, we just don't call it a function. You could still produce its graph, okay? It still may have an equation that you could use to connect the 2 points. It's just not classified as a function. On a graph, you can use the vertical line test, which basically states that you can draw a vertical line anywhere on the graph. Okay, vertical line means it has to be straight up and straight down, and it will only touch the graph at a single point, okay? For example, if I were to go right here, draw a vertical line, or roughly a vertical line, I can see on that curve, it touches the graph at one point, specifically right here, right? If it failed, like on this one, the graph of a circle, here you can see clearly it crosses twice, okay? So do these represent functions? This first one, yes. Okay. Second one, no, it doesn't, right? We didn't work with the equations of circles. Sometimes we do, sometimes we don't. I don't think we have this year. It's kind of a big, I mean, it wouldn't be crazy for us to do that. It's a little bit bigger equation. It's got a big square root sign and then a lot of stuff going on underneath. Creates a cool graph. Nice to be able to graph a circle, right? There's nothing wrong with that. It violates the definition of a function. Right here, looks like both of those look linear, right? It's got two kind of separate lines going different directions. The fact that there's a gap in the middle is okay, right? I can have a point where it doesn't touch it at all. That's okay. To pass the vertical line test and call the graph a function, it just can't touch the vertical line twice in the same spot, okay? So everywhere I draw that vertical line, it can touch it once, okay? It's okay if there's gaps, okay? 1 time, 0 times. Either way it works. All right. I'm going to go back to algebraically finding some zeros. This is always like, A good skill to have, because if there was one skill that would come up with functions that would show up most often in word problems, like we need a variety of algebra skills to solve word problems. But finding zeros might be one of the most important, just because if functions are non-linear, and that's kind of the direction we're headed. We've spent a lot of time on lines, and we're kind of moving in this non-linear direction, right? So far, we've really went at it in chapter 1b with quadratics. But that's kind of the direction we're going. We got to be able to find zeros, right? Any time we have to solve, we somehow need to set up our equation that's what we're doing. So if it feels like we're doing it a lot, we are, because it's really important. We'll start with one that's a little more familiar, okay? It's quadratic. Again, this is the one type of nonlinear function when it comes to finding zeros that we've seen a lot this year. You can go quadratic formula if you want to. This guy is factorable. Okay. That should, 3 times 2 is 6, negative 5 times 1, right? That gets me to a middle term of x. Kind of our more typical case with the quadratic, we're going to get 2 zeros. Fraction for the other one. At 5/3. Okay? Now here's one with a big square root. I'm going to make sure we don't get these two confused. It's got a big square root. Okay? We haven't looked at the square root function hardly at all. I don't know if or when we will. Like, you'll see them, and we'll do some basic things with them that I think you can handle. I don't know if we'll have like a full section to devote to the square root function. But just start. I mean, the quadratic is kind of the one type, like the one we just saw, where you have to look at it a special way. Others, you can just kind of use your inverse operations to solve. Okay, we'll see polynomials. Right, polynomials meaning, like if this term was not just to the second power, but third, fourth, those you kind of have to do differently. But this isn't the case. So I could undo that square root with a square. Add x squared to both sides. Top it off with the square root. Now we get plus or minus the square root of 10. Last one is rational. Okay, looks terrible, right? Like we're going to set that whole thing equal to 0. Here's what you need to know. Okay, if you were to come, because this is a little bit more common function type that I don't know exactly when we'll see them, but we will. We'll dive in much closer to rational functions. If we want to find their zeros, all that matters is the top, right? So when I'm saying rational, I'm saying you've got a function up on the top and you've got a function on the bottom. For finding zeros, the function on the bottom does not matter, okay? If I'm just saying what values make the function equal 0. The bottom is a whole different deal. The zeros at the bottom are, if we find those, it would be where these things called vertical asymptotes are. We're getting ahead of ourselves there, right? So just the bottom, like finding those zeros would have a purpose. It just doesn't cause the function to take on the y value of 0, okay? So all we really have to do, we're free to disregard the bottom, is just look at the top. In this case, it's a line. Most of the rational functions we'd look at, you would find the function that's on the top, probably one you're familiar with, and we've covered how to solve it. Add 3, divide by 2. The only value that would make that function equal 0 would be 1.5 or 3 over 2. That would be the only one. All right, that's all for day 1. Quick preview of day 2, more reading graphs. Just kind of a couple specific things that when it comes to getting information from graphs that we just didn't talk about yet. That's what's coming in day 2.